Hello my dear learners, I am Dr. Pawan Kumar Shukla, professor at RKGIT Ghaziabad in Electronics and Communication Engineering department. I was going through the AKtU video lectures of the subject antenna and wave propagation. In my last few lectures, I was discussing about the antenna array. What are the arrays, what are the different classifications of antenna array, how an antenna array works, and what are the advantages and the different applications of antenna array in the present scenario of the applications in the field of antenna. Today, I will discuss some of the very specific concepts in the antenna array field, because the conventional type of antenna arrays like broadside and end fire, either it may be the case of 2-point sources or it may be the case of n-point sources. We have already discussed all the radiation patterns and all kinds of advantages and disadvantages, what are the problems which are arised during the design of all such kind of antenna arrays. We have discussed already these things. So, I will discuss some very specific and very important concepts in the antenna array theory. So, my today's lecture is based on the concept of phased array, or you may say that adaptive array types. So, I am going to start the lecture with the basic theory of phased array. What are the phased arrays? Basically, these are the different kinds of arrays which are having a unique characteristics of the radiation pattern, and basically as we have already studied about the broadside and end fire, the conventional cases of antenna array. In the case of broadside array and the end fire array, the maximum radiation is obtained by adjusting the phase excitation between the elements in the direction normal and along the axis of array respectively. These are the two important things when we allocate a phase shift between the adjacent elements of an antenna array system and the spacing between the elements. And according to this adjustment, we can find the radiation patterns accordingly. In other words, elements of antenna array can be phased in a particular way to get the desired output in terms of radiation pattern. So, we can obtain an array which gives maximum radiation in any direction by controlling the phase excitation in each element. This is the basic theme of phased array. Like this term phased implies that the phase of the individual element of the antenna array can be adjusted to get greater directivity or to get the desired output. The array in which the phase and the amplitude of most of the elements is variable, provided that the direction of maximum radiation and pattern shape along with the side lobes can be controlled, it is called the phased array. And in my today's lecture, we will discuss the different kinds of such antenna array system in which the controlling of the radiation pattern is based on the phase of the different antenna or elements of the array system. The elements of array are considered as lambda by 2 dipoles antenna, not as the case of hypothetical isotropic radiators or the point sources. So, practically we can consider the elements of the antenna array system in the phased array case. We take the antenna elements like lambda by 2 dipoles antennas, and all the cables used are of same length for the phased array system. All the 3 cables which are used to form the phased array system are brought together at common feed point. Here mechanical switches are used to define the feed analysis or the feed system excitation system in such kind of antenna array system. Such switches which are used in the form of mechanical switches are installed in a way that one switch should be at each antenna and one switch should be at a common feed point. In the case of antenna array system, basically feed point is the point from where we can excite the individual element, and this feed system and the current through which this element is being excited is the measurement of the phase. So, to make operation reliable and simple, the ganged mechanical switch is replaced by pin diode which acts as an electronic switch. But for the precision in result, number of cables should be minimized, and suppose the array gives maximum radiation in the direction as phi equal to phi naught, where phi naught is ranging between 0 to 180 degree, then the phase shift that must be controlled and it should be obtained in such a way that the overall radiation pattern is in our favor. The electronic phased array operates on the same principle, and suppose we consider a 3 element phased array system like this. In this particular diagram, you can see here that 3 elements in the form of lambda by 2 dipoles are placed to form an antenna array system, which is in the form of phased array, and the feed points which are given by the different switches, and here the feed point is practically given at this point, which is point number 1 and point number 2. So, you can see here that what are the importance of the switches in a phased array system. This is the simplest form of phased array system. The different components in phased array system, in many applications phase shifter, generally this is a device, this is a component which is used in the phased array system to control the phase by the switching cables. It can be achieved by using ferrite devices. The conducting wires are wrapped around the phase shifter. The current flowing through these wires controls the magnetic field within ferrite, and then the magnetic field in the ferrite controls the phase shift. So, by using the different kinds of phase shifter in the phased array system, we can improve the performance of the array system. Frequency scanning array is also a kind of phased array system. Some of the modifications, some of the changes have been done in a conventional phased array system, and we can get the frequency scanning array. Some of the special advantages can be achieved by designing such an frequency scanning array, and the array in which the phase change is controlled by varying the frequency, it is called as the frequency scanning array. It is found to be the simplest phased array, as at each element it separates phase control it is not necessary. For the individual element, if we control the phase, it is not possible in the complete array system which is having n number of elements or components. A simple transmission line fed frequency scanning array is shown in the given figure, and in this figure you can say this is also a very simple kind of frequency scanning array, in which we have used some matched terminations for getting the resonance condition between the different antenna elements in this phased scanning array system, and the directional couplers are also utilized to fix the positions while beam scanning is done with the frequency change. So, the frequency change is the factor which performs the operation of simply the phase change. These are the advantages of frequency scanning array. Why we use the frequency scanning array? The transmission line is properly terminated to the load to avoid reflections. Obviously, matching is done just to avoid the reflections, so that the standing waves are not generated, and also as well as when the backward directions waves are not creating. So, the losses are also very less, and at the condition of resonance only the resistive load will be there, and the performance of antenna array system is also improved. There are no moving parts in it, no switches and phase shifters are required in frequency scanning array system. A very special kind of array system is retro array. This is the array which automatically reflects an incoming signal back to the source, which is called retro array. It acts as a retro reflector similar to the passive square corner reflector. That means, the wave incident on the array is received and transmitted back in the same direction. This is called retro array, and the simplest form of the retro array is the Van Atta array as shown in the given diagram. And this Van Atta array, it is a kind of retro array which is having the 8 identical dipole elements which are used in this given antenna array system, and with the pairs all the elements in the array systems are paired between elements 1 and 8, 2 and 7, 3 and 6, 4 and 5 using cables of all the equal lengths. If the wave arrived at angle say phi, then it gets transmitted in the same direction. This is the property of retro array system. Adaptive arrays. Adaptive arrays, they are also a very unique kind of array system which are utilized in the antenna array theory. These are the arrays which automatically turn the maximum beam in the desired direction while turn the null in the undesired direction, which is called as the adaptive array. The adaptive array adjusts itself in the desired direction with awareness of its environment. In modern adaptive arrays, the output of each element in the array is sampled, digitized and then processed using computers. So, we can say that these are the array system which are having their analysis on the different softwares, and by using the different computer system we can analyze, we can sample or we can simulate the results and output in the form of radiation pattern itself. Such arrays are commonly called as the smart antenna or smart antenna system. So, these are very advanced and modern antenna array system. Principle of antenna synthesis or binomial array. To start this particular topic, binomial array, I just want to draw your attention on the previous theory of antenna array, in which the major concern was to eliminate the minor lobes, side lobes, back lobes, because in a complete radiation pattern we are required only one particular lobe, which is known as major lobe, and all the energy, all the power, all the field must be constrained within the lobe of major itself. Any kind of side lobe, minor lobe or back lobe, it is the factor which reduces or which is used as the loss of the energy, which is the loss of power which is radiated from the antenna or which is being received by the antenna. So, our main focus is to eliminate all kinds of lobes other than the major lobe. Obviously, major lobe must be having a very sharp beam width, because the directional characteristics are in the form of its sharpness of the beam, sharpness of the major lobe. So, generally in the binomial array, our main focus is to eliminate all kinds of the other lobes other than major lobe. This is the basic theory, this is the basic theme of using binomial array, and obviously as its name suggests, binomial, obviously we use the binomial expression to define the non-uniform amplitude distribution in the different elements of this kind of antenna array system. So, in case of uniform linear array, to increase the directivity, the array length has to be increased. But when the array length increases, the secondary or side lobes appear in the pattern, which are definitely the loss of the power, and we have to eliminate all such kinds of lobes. In some of the special applications, it is desired to have single main lobe with no any kind of minor lobes. This is the requirement to get the binomial array, and that means the minor lobes should be eliminated completely or reduced to minimum level as compared to main lobe. To achieve such pattern, the array is arranged in such a way that the broadside array radiate more strongly in the center than that from the edges, and the pattern of this kind of antenna array system in which the resultant radiation pattern is having only one single major lobe, all the minor lobes, side lobes, back lobes, all these lobes are having have been eliminated from the radiation pattern. For getting this particular type of antenna array system, John Stones proposed a pattern in which the non-uniform amplitude distribution is according to the coefficients of a binomial series or binomial expansion, and this binomial expansion can be given as 1 plus x to the power m minus 1 is equal to 1 plus m minus 1 x plus factorial m minus 1, factorial m minus 2, factorial m minus 3, and so on. So, these are the different factors in which we can propose the things like NCR, means NCR is the coefficient, and this coefficient is responsible for the amplitude distribution for the different elements in this binomial antenna array system. These coefficients form the Pascals triangle. Like if any binomial antenna array system is having one element, it is having one single amplitude of the current which is known as 1. If it is having two elements, these are having amplitude like 1 1. If it is having three elements, it will have the amplitudes as 1 2 1. If it is having 4 elements, the amplitude can be divided like 1 3 3 1, and so on. You can see here that when the number of elements can be increased as 10, you can see that this kind of amplitude distribution triangle is formed. But some of the properties are very important, that the first and last element is always having an amplitude as one single, one unit, and the sequence of the different amplitude is the increasing up to the middle, means the middle element is having the highest amplitude in the binomial array system. So, these are some of the findings of binomial antenna array system. This is a general non-uniform amplitude array with odd and even elements. When the odd and even elements are given, you can identify and you can form the different antenna array system by using these formulas. Simply, this is analogy in which the different number of components, when two elements are taken, then 2m equal to 2 and a1 is equal to 1. When 3 elements, that is A1 is equal to 1, A2 equal to 1, 4 elements, A1 equal to 3, A2 equal to 1, 5 elements and so on. So, you can achieve the different coefficients in the binomial array system, and binomial arrays do not exhibit any minor lobes provided the spacing between the elements equal or less than 1/2 of a wavelength, because this is a primary condition which was given by the John Stone to form a binomial array system. The design using a lambda by 2 spacing leads to a pattern with no minor lobes. The half power beam width and maximum directivity for spacing or distance between two elements when it is equal to lambda by 2, spacing in terms of the number of elements or the length of the array are given by HPBW, half power beam width, and the maximum directivity in these expressions. So, this is the final theory of the binomial array system. These are the advantages and disadvantages. The biggest advantage of binomial array is that there are no any number of side lobes or minor lobes in the radiation pattern, and the disadvantages are that beam width of the main lobe is larger than the other type of conventional antenna array systems like broadside or end fire or uniform or any other kind of antenna array system, because we have to eliminate all the other lobes. So, the major lobe is having some of the larger beam width. Directivity is small and high excitation level are required for the center elements of large arrays. You can see the distribution of different elements in the antenna array system. So, this was all about such kind of arrays which are very much popular and important nowadays, and they can be applied for the modern theory of it may be in the form of antenna theory or in other applications of the communication system. So, thank you very much for watching this video. In my next lecture, I will discuss some more important topics related to the antenna. Thank you very much.